Hello there, welcome to lesson number 4 in our Unit 3 Solving Quadratic Equations for our MCF3MI class. Over the course of the unit, we've been through the 3 different methods for solving quadratic equations, whether it was rearranging and taking square roots, factoring, or using the quadratic formula. Today is this particular lesson is sort of a more of an exploration lesson, so we're going to skip a lot of that exploration because it's not nearly as fun when I'm just telling you how to do it and we're not working through it as a group. So this lesson will be a little bit shorter, I think. It actually starts off by considering given quadratics in different forms. So if we think back to the unit before this, Unit 2, we know that quadratics come in factored form, standard form, and vertex form. And if we're trying to find the roots, the solutions, those x-intercept values for our quadratic equations that would correspond to those versions of quadratics functions that you would see, how do we know how many solutions there might be? So we're going to look at the 3 different forms. The first form that we're going to look at here, and again it'll be a lot more copying today and not so much of the doing of the math until the very end of the lesson. I'll just do some talking, I guess, like usual. If we're given factored form, what we need to do is just find the x-intercepts, and those x-intercepts would then correspond to our solutions. So for example, if we had y equals bracket x minus 4 close bracket, open bracket x plus 2, that's a factored form version of a quadratic. We know that the x-intercepts will be the x values that will drive these brackets to be equal to 0. So the 2 values that will work for us will be 4 and -2, and that means that we will have 2 zeros. And all 3 of our examples sort of work like that. The only one that's a little bit odd is the second one where we have -2x and then bracket x minus 5. A way to write this that might be a little bit more clear to you, and we did this when we were doing our graphing, would be to write this as -2 and then x plus 0 and then x minus 5. So recognizing that if it is something like x plus 0, they're just going to collapse that bracket down, but it doesn't change the fact that one of our 2 x-intercepts, or in this case one of our 2 solutions, would be x equals 0. And the last one has just 2 identical binomials when it was factored out. So if you're given factored form, you'll know that there are x-intercepts, i.e. solutions, for the quadratic equation that you're working from. In vertex form, this requires a little bit different work. If we have here 2 bracket x minus 4 all squared minus 3, what we recognize is that we have a vertex at 4, -3, and that our parabola opens up. So what this means is that if our vertex is below the x-axis and our parabola opens up, there will necessarily be two solutions for that quadratic equation. The same idea for the next example. We have -2 x minus 4 all squared minus 3, and in this particular case we have a vertex that is below the x-axis, but our parabola opens down, so there will be no x-intercepts or 0 solutions in the context of this unit. The last example is y equals 2 x plus 7 all squared. This particular parabola has a vertex that sits right on the x-axis, and in those cases, if it's sitting right on the x-axis with a k value equal to 0, then we will have one x-intercept, which corresponds to one solution for our quadratic equation. So those are the 2 forms that we haven't really looked at in this unit yet, in ways to tell how many solutions there's going to be for a given quadratic equation. Because that's what this lesson's sort of about, is we've looked at all these tools so far, but is there a way that we can find out in advance how many solutions we're going to have for a given quadratic equation? Because it's a bit of a pain to go all the way through trying to factor it and then try using the quadratic formula only to find out that there are actually going to be no solutions or no x-intercepts if we're talking about quadratic functions. So this next page of our lesson deals with standard form, and there's a lot of math on here. I'm just going to encourage you to copy it down. this, as I said, is more of an exploration. It's designed to help you recognize that given particular quadratics, so in this case 4x squared minus 2x minus 3, when we go through the math of finding the vertex and using the quadratic formula to find the solutions, I'm hoping, or in class we would be hoping to identify a pattern in the different quadratic equations we've been given, something that might give us a clue as to how many solutions there's going to be. So in this first one, 4x squared minus 2x minus 3, there are, as you can see from the answers and the sketch, there are going to be 2 solutions. The second example, 5x squared minus 12x plus 9, you'll see that there are no solutions. And what I want to point out here from this middle box is that when we work through the quadratic formula, we find out that we end up with a negative value under the radical sign. And as we know from rearranging and square rooting, anytime you have a negative value under the radical sign, you're not going to have any real solutions. The third example, x squared minus 2x plus 1, you'll see that when we work it through, it turns out there is only one solution because we actually have a 0 under the radical sign. So let's just look back up through this work, and again just pause this video and copy this stuff down so you can get a look at it. But here we have a 0 under the radical sign, and that led us to only one solution. Here we had a negative value under the radical sign, and that led to no solutions. And here we had a positive value under the radical sign, and this led us to 2 solutions. So this is sort of our takeaway from this video, is that depending on the number that's under the radical sign, we can actually make predictions about how many solutions there's going to be for our quadratic equation. That value that sits under the radical sign in the quadratic formula is called the discriminant. It has a name because it's important. And the discriminant allows you to predict, and that's just the value there that's under the radical sign, b squared minus 4ac. If you were to take a standard form version of a quadratic equation and substitute in the appropriate a, b, and c values, the number that you get for your discriminant will predict the number of roots that you will have, the number of solutions. So these are just rewritten versions of the discriminant from the question above, but because we didn't really work the questions from above, let's at least do a little math today, and we'll do them here. So our discriminant is equal to b squared minus 4 times a times c. And let's work this out a little bit at a time here. So that's going to be 4 plus 48. And that's going to give us a discriminant value of 52. And as we know from above, this tells us that there are going to be 2 real roots for that particular question. So with a positive discriminant, we have found that there are going to be 2 real roots. Let's have a look at the second example. We're going to do our b squared minus 4 times a times c, and that's going to give us 144 minus, let's see, what is that? Oh, math. I'm recording this early in the morning, and my brain's not 100% on yet, so I'm going to do a bit of a cheat here and just use my calculator. So let's see, we have 4 times 5 times 9, that's going to give us 180. And when we do that bit of math, we end up with a negative 36. And a negative 36, of course, now that negative value is going to correspond to us having 0 real roots. Final example, we take our b squared minus 4 times a times c. That's going to equal, oh, I'm sorry, made a little copy error there. That should be a 1. And that's going to give us 4 minus 4, which is going to give us a discriminant value of 0, which we know corresponds to 1 real root. So the real takeaway from this lesson is that using the discriminant, you can predict how many real roots you're going to have for a question. Maybe save yourself some time going through the hassle of trying to solve something that will not have any solutions at all. So this is our summary. If our discriminant value is greater than 0, we're going to have 2 real roots. If our discriminant value is less than 0, we will have 0 real roots, and that's a negative number, and that sort of gels with what we've been talking about earlier. And if our discriminant value is equal to 0, it means we're going to have 1 real root. So now we're just going to work a couple of examples just to sort of do the predicting piece. Now I want to point out that when it says like this, determine the number of roots without solving or graphing, what we're doing here using the discriminant is not solving or graphing. Solving is like using the quadratic formula or solving it by factoring or rearranging and square rooting. Without solving means using the discriminant, let's make a prediction based on the discriminant value we arrive at. So let's do one of these examples here together. In this one, x squared minus 4x plus 3. Let's substitute in, so we're going to go with negative 4 squared minus 4 times a times c. And that's going to give us 16 minus 12. That's going to give us a 4. So our discriminant value is going to be 4. So what does this tell us? Here's how we would write it as a way of sort of explaining it. So we would say since the discriminant is larger than 0, the quadratic will have 2 real roots. And this would be true of any positive value we arrive at. Let's work our second example. So our discriminant will be 2 squared minus 4 times negative 1 times negative 3. That's going to give us 4 minus 12, or negative 8. So our discriminant value is negative 8. That's a negative value. So we would write this, first stating what we know about the discriminant from our calculations. So the discriminant is less than 0. Therefore, the quadratic will have no real roots. So that's our lesson on the discriminant. Again, it's a predictive tool to determine exactly how many solutions you're going to have when you do go through the effort of solving for the quadratic equation you've been provided. So this was lesson number 4. We have one more lesson in this unit and then we're all done. So give that homework a try. If you have any questions, you can email me, and otherwise, good luck.